Hello everyone, welcome back to this online class. Today we are going to look at the third form of integrals under trigonometric and hyperbolic substitutions. That is integral of the form, the integral of 1 over the square root of x squared plus a squared with respect to x. So how do we go about it? So again here, just as usual, we need to factor out the constant a, that is a squared from the square root, so that we get this. If we factor out a squared from the square root sign, that is from the denominator, that integral can now be written as 1 over a times the integral of 1 over. Now, because a squared is outside, so we'll have the square root of x squared over a squared. Or let me start with 1. The square root of x squared over a squared plus 1. This I can write this as the square root of 1 plus x squared over a squared dx. So now again, go back to the trigonometric and hyperbolic identities. Check which one plus which function gives you another function. If you look at the identities, take note that we said 1 plus tan squared theta should be able to give us sec squared theta, but in the denominator here we have square root, so I cannot use that identity. This is the identity that I will use. You know, we have we know that cos hyperbolic squared theta, when you subtract sine hyperbolic squared theta, we should be able to get 1. So remember, I want 1 plus something. So I can decide to take the sine hyperbolic squared theta to the right hand side, so that we'll have this as 1 plus sine hyperbolic squared theta. That should be able to give us cos hyperbolic squared theta. So remember, I wanted 1 plus something squared should give us another trigonometric or hyperbolic function squared. And you can see in this case, we have 1 plus hyperbolic sine theta squared is equals to hyperbolic cosine theta squared. So I now do the comparison. We have 1, when we now compare, we have 1 plus x squared over a squared. So if you do the comparison, what do you find? You realize that 1 can be compared to 1. They are the same. So we can now as well say that x squared over a squared should be equal to hyperbolic sine theta squared. So from here, you can say that x squared over a squared should be able to give us sine hyperbolic squared theta. And what you do here is make x the subject. So from here, you can just say therefore in this case, our x will be equal to a sine hyperbolic of theta, or simply hyperbolic sine theta. Remember, x squared is equals to a squared hyperbolic sine theta squared. And then you take the square root on both sides so that you get x is equals to a times hyperbolic sine theta. That is the substitution that you need to make. And I told you that every time you make a substitution, you must be able to find the corresponding differential, because we also need to know what will be dx. Look at our integral, there's dx, so we need to replace even that one. So I'll have to differentiate x with respect to theta so that we get this. So you can write dx d theta. You can write therefore dx over d theta. What will it give us? Remember, a is a constant. And you know, when you differentiate sine hyperbolic of theta, you should be able to get cos hyperbolic of theta. So you can make dx the subject. From here, we are going to get dx equal to a times cos hyperbolic theta d theta. So this is the corresponding differential that I was talking about, that every time you make a substitution, you must know the corresponding differential. So you see what I've ticked? Those are the ones that we are going to substitute in our integral. So when you substitute, what do we get? Our integral will now become, so we can say, therefore, we will now be having 1 over a, the integral of 1 over the square root of 1 plus, what is x squared over a squared? Where there is x, you put a sine hyperbolic theta. So that should be able to give us, because x squared over a squared, that is sine hyperbolic squared theta. So you write here sine hyperbolic squared theta. Then instead of dx, that would be a cos theta d theta. So that this will give you 1 over a, the integral. Now, what is 1 plus sine hyperbolic squared theta? That is cos hyperbolic squared theta. And because you have the square root, when you take the square root of cos hyperbolic squared theta, we get cos hyperbolic theta. So you see, we'll have now 1 over cos hyperbolic theta. Then times, I can see this a cos, or simply cos hyperbolic theta d theta. And you see some terms will cancel, like a here will cancel with this a. This cos theta will cancel with this other one. So what you remain with is the integral of 1 d theta, or simply d theta, which will give you theta plus c. But what is theta? Go back to where we defined our theta, our substitution, and you realize that we said x is equals to a sine hyperbolic theta. So you make theta the subject. You first of all divide by a so that we have x over a is equals to sine hyperbolic theta. So you now need to take sine hyperbolic inverse on both sides, so that in this case our theta is sine hyperbolic inverse of x over a, and this is added to c. So, but what I wanted you to master is, when you have this form of integral, where do we start from? You need to know that when we have a square root in the denominator, and that function squared is added to the constant squared, then don't use tan. I know also 1 plus tan squared theta is equals to sec squared theta. But why are we not using that identity? Is because of the square root in the denominator. That's why we are using the hyperbolic substitution in this case. So take note that in this case, that function is equal to a sine hyperbolic of theta. I am going to give you an example to illustrate this. For instance, we can have example or e.g. Let's have this as example. Let's say you are asked to evaluate this. Let me call it part A. You are asked to evaluate the integral of 1 over the square root of x squared, and this is added to 4 dx. How do you go about this one? Again, it is in the form of the integral that we have just discussed. And in this case, for you to be able to solve it, you must start by saying that because here, take note that our a squared is equals to 4. So in this case, it means that our a must be equal to 2 because the square root. So what is the substitution in this case? We're going to say let x be equal to 2 sine hyperbolic of theta. Why are we using 2? Because we said x is equals to a sine hyperbolic of theta. So what about dx? Differentiate, you'll get dx being equal to 2. Derivative of sine hyperbolic theta is cos hyperbolic theta. And then remember, we are differentiating with respect to theta. So when we substitute in this integral, what do we get? It will now be the integral of 1 over, so here we have the square root of x squared. But instead of x, I need to replace it by 2 sine hyperbolic squared theta. So I'm going to rub what I've written here because we want this integral or the integrand now to be a function of theta. So when we square x, we are going to get 4 sine hyperbolic squared theta, then plus 4. Then instead of dx, again, instead of writing dx, I am going to write that is 2 cos or cos hyperbolic squared theta. So that is times 2. This is cos hyperbolic theta d theta. You see, we have replaced dx and you have also replaced x because we want our new integral or the integrand to be in terms of theta, not x. So when I simplify this one, in the denominator, you can see there's 4 that is common. You can take that out of the square root so that it becomes 2. Square root of 4 is 2. And remember, 2 is a constant. So we'll have 1 over 2, which you can factor out. A constant can be factored out so that we have 1 over 2. And now we remain with 1 over the square root of sine hyperbolic squared theta plus 1 times, I can see there's another 2 cos hyperbolic theta d theta. Now let me ask you, what is sine hyperbolic squared theta plus 1? Look at the identity. We said that is the same as cos hyperbolic squared theta. And because it is under the square root, when you take the square root of cos hyperbolic squared theta, that will give us cos hyperbolic of theta. So you realize that the whole of this number that we have under the square root is the same as cos hyperbolic of theta. And you see the 2 here will cancel with the other 2. So finally, what I remain with is the integral of 1 d theta, which I can just write as integral of d theta. And because integral and derivatives are inverses of each other, they'll cancel, so that this will give you equal to theta plus a constant c, constant of integration. So that is our answer, but it is advisable that you leave your answer in terms of x. So we must replace theta. So you need to check, where have we defined theta? You realize that our theta came from this equation. This is where we got theta from, that x is equals to 2 times sine hyperbolic of theta. So make theta the subject. From that equation, if I divide by 2, we'll have x over 2 is equals to sine hyperbolic of theta. Then when I take sine hyperbolic inverse on both sides, you get theta is equals to sine hyperbolic inverse of x over 2. So that's what I write here, that our answer will be equal to theta, which is sine hyperbolic inverse of x over 2. And remember, there's a constant c of integration. So I told you every time you must add the constant of integration. So thank you all for watching this. Next time when we meet, we look at the fourth form of the integral under hyperbolic and trigonometric identity. Don't forget to subscribe to my channel, Professor Francis Okech. Also, don't forget to share, comment, and like my channel and my posts. Thank you.